Good day, viewers. It's the indices. And the first question before us is solve the equation 3 raised to power x equals 1 over 81. So this is a very basic question, and we are going to treat it as it is. We proceed. 3 raised to power x becomes 81 raised to power negative 1, because according to one of the laws of indices, 81 raised to power negative 1 is going to give us 1 over 81. So this and this are one and same. Again, 81 is one of the lineage of 3. So we can have this equation becomes 3 raised to power x equals 3 raised to power 4 firstly, which represents 81. Why? 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So 3 to the 4th power is going to give us 81. Not forgetting that this 81 was raised to power negative 1. So 3 raised to power 4 is 81. 81 raised to power negative 1. Now, according to another law of indices, when you have 3 raised to power 4 and then raised to power negative 1, it is the same as 3 raised to power 4 multiplied by negative 1. So this becomes 3 raised to power x equals to 3 raised to power negative 4. And of course, these two bases are one and same, so they can cancel out. That implies that our x equals negative 4. Very simple and straightforward. Next question. Solve the equation 3 multiplied by 3 raised to power x equals 27. By general knowledge, the presence of this bracket tells us that this 3 is multiplying what is inside this bracket. Okay, so we are going to have to rewrite this equation. And to do that, we'll be having 3 multiplied by this x affects only this 3 that is in this bracket. It does not affect this 3 outside this bracket. That is why this 3 here is not carrying x. So this becomes 3 multiplied by 3 raised to power x, which is what we have here. And that's equal to 27, the right hand side of the equal sign. Of course, this can be rewritten again as 3 bracket open, 3 to the x power, close bracket equals 27. Now this x there, we've been able to bring it into the bracket here. Now what's the next thing? It is to collect like terms. 3 is not having any variable with it. Likewise, 27 is not having any variable with it. So I can say this 3 and 27, they are like terms. So for us to collect them together, we'll be having 3 bracket open, 3 raised to power x divided by 3 equal to 27 divided by 3. Most people will say divide both sides by 3. It's also a way of collecting like terms. So this 3 cancels this 3. We'll be left with 3 raised to power x on the left hand side of the equal sign. And this is going to be equal to 27 divided by 3. That's going to be 9 on the right hand side of the equal sign. Of course, 9 is also in the lineage of 3. So 3 raised to power x becomes 3 raised to power 2, because 3 to the 2nd power gives us 9. As before, the two bases are exactly the same. That implies that our x equals 2. Also simple and straightforward. Question 3. Solve the equation 0.25 raised to power x plus 1 equals 16. So this carries a decimal fraction, as you can see here. So to start with, we're going to convert this decimal fraction to become an exact fraction. And 0.25 can be written as 25 over 100. How is that? 0.25 is the same thing as 0.25 over 1. And that becomes 25 taking away the 0 point over 1. And after the decimal point, how many digits are we having? 2 digits. So we're having 2 zeros. That is why 0.25 becomes 25 over 100. And that's raised to the power x plus 1 equals 16. Now when reduced to the lowest term, it becomes 1 over 4 raised to power x plus 1 equals 16. So you can see that this is taking shape already because there's a relationship between 4 and 16. Of course, 1 over 4 and 16. Now, 1 over 4, also according to the law of indices, one of the laws of indices, is same as 4 to negative power 1, now raised to power x plus 1 equals 16. So, most people want to deal with 16 as 4 to the second power. That's 4 raised to power 2 equals 16. It's a very nice concept. But I recommend that you work in the simplest base possible in both sides, on both sides of the equal sign. I have my reasons for that. So for us to work with the simplest base possible here, 4 is same as 2 raised to power 2. So 2 raised to power 2 equals 4. Then this 2 raised to power 2, which is 4, is now raised to power negative 1, as we have it here. And of course, this is also all together being raised to power x plus 1. 2 raised to power 2 is firstly 4. 4 is now being raised to power negative 1. Then 4 raised to power negative 1 is now being raised to power x plus 1. So each bracket has a story to tell. And this is going to be equal to 16 is 2 to the 4th power. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So 2 raised to power 4 gives us 16. Okay, so we are going to have to expand this bracket one after the other. 2 raised to power 2, then raised to power negative 1. That is 2 raised to power, according to one of the laws of indices, this 2 will multiply this negative 1. And again, together multiply x plus 1 equals 2 raised to power 4. Follow me, no issues. 2 times negative 1 is negative 2. So that becomes 2 to power negative 2, bracket open, x plus 1 equals 2 to the 4th power. I'm taking them one step at a time because we don't need to rush ourselves. Okay, so that becomes 2. Negative 2 times x is going to be negative 2x. Negative 2 times positive 1 is still going to be negative 2. And that's going to be equals to 2 to the 4th power. Like we did in the first and the second questions, the two bases are exactly the same. So we can take them out. And when we take them out, what will be left with is to equate the powers. So we have negative 2x minus 2. Negative 2x minus 2 equals 4 on the other side of the equal sign. And again, we collect like terms. Negative 2, or the 2 here and this 4 They are like terms. So negative 2x has to leave here, to remain here. So negative 2 leaves here to come and meet 4. Okay, when it crosses the equal sign, it becomes positive 2. Of course, it does not have leg to cross. Now, what is the idea of negative 2 crossing the equal sign? The additive inverse of negative 2 is positive 2. So we have to add 2 to both sides. And that's minus 2 plus 2. Now, this plus 2 was not there. It was added to this side. So definitely, it has to be done to the other side of the equal sign also. That's 4 plus 2. So that this minus 2 plus 2 deal with themselves. And then we have negative 2x equals to 4 plus 2. In most cases, we don't bring these things out like this. We just move negative 2 to the other side of the equal sign and we say it becomes plus 2. You are good to go. But you need to know the reason behind that. That is why I have to spell this out one by one. So we have negative 2x equals 6. What do? We divide both sides by negative 2. So we have negative 2x divided by negative 2 equals 6 divided by negative 2. Of course, negative 2 is going to take out negative 2 here. We'll be left with x. And that's going to be, the sign for 6 is positive. The sign for 2 is negative. Plus divided by minus will be minus. 6 divided by 2 will be 3. And so, our x is negative 3. A bit lengthy, but very easy. The last question in this session. 4 over 2 raised to power x equals 64 raised to power x. Okay, so this is in the form of a fraction and this is in the form of a whole number. So we have to bring this also to the fraction format to bring out the homogeneity in both sides of the equal sign. So the next thing is what you are actually used to, very common, cross multiply. 4 multiplies 1, 4 times 1 equals 64 raised to power x multiplied by 2 raised to power x. Now 4 times 1 is 4 and 64 raised to power x. 64 is firstly 2 to the 6th power because 2 multiplied by 7, 6 different places gives us 64. 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32, and times 2, 64. So 64 is 2 raised to power 6. It is now being raised to power x. And this is to be multiplying 2 raised to power x also. So we can simplify. 4 also is 2 raised to power 2 because 2 raised to power 2 is 4. And this is 2 raised to power 6 multiplied by x, 6x, then multiplied by 2 raised to power x. Okay, now we see that all the bases are one and same, but we cannot cancel out the bases yet until there is only one base on this side of the equal sign and only one base on this side of the equal sign. And those two bases on both sides of the equal sign are one and same. So we'll be having 2 raised to power 2 equals, according to the very first law of indices, 2 raised to power 6x plus x. When the bases are exactly the same and they are multiplying themselves, all you need to do is to just add their powers. So we have 2 raised to power 2 equals 2 raised to power 7x. Now, the two bases are one and same, and we have just one on each side of the equal sign. So we can take them out. So we have 2 equals 7x. And of course, to make x the subject, which is the value, the variable, the value of the variable that we are looking for, we divide both sides by 7 because the coefficient of x is 7. So we have 2 divided by 7 equals 7x divided by 7. This 7 takes out the 7. You'll be left with x on only on this side of the equal sign, or of the equation rather, or the equal sign still equals 2 over 7. And this brings us to the end of equations under indices. This is one aspect of the equation under indices. So I'll be coming up with the other aspects of equation under indices. In the meantime, enjoy yourself with this. Thank you.